Hello everyone, my name is Sandeep Lohia and I'll be presenting along with Krishna Venkatraman today. Hi Krishna.
Hello, everyone. Thank you for joining us today. We look forward to sharing our story on cell-side router automation and along the way, unearthing several dimensions of NSO. With that, I'd like to invite Sandeep. Please, you want to go over the agenda and get us started?
So today we'll be presenting a customer use case study for a tier 1 service provider in the USA. How NSO can expedite cell site router deployment using zero touch provisioning or the ZTP technology. So let's have a look at the agenda. So I'll briefly go over the automation challenges and problems faced by the service providers and the overall solution architecture. Then Krishna will deep dive into the 2 use case studies. And finally, we'll share the business outcomes and the benefits of this solution. So with the mobility and data usage growth and with upcoming service providers are facing tremendous challenges. And this is a glimpse of it. Most often, the legacy devices carry non-standard configs, and some have decades of history. Upgrades or changes are handled by manual processes, which are time-consuming and error-prone. Sometimes the changes made to the network is in a cheat sheet kept in an operator's drawer. So the current way of managing the network is not scalable, and there is a risk of missing the growth opportunities. And to add to the problem, due to OpeEx cuts and OpeEx pressures, more work is expected from the reduced team size. So this is where customers start thinking about automation, and that looks easy, huh? So this is the point from where we start, and it is not just about device configuration or device automation. In service providers world, there are lots of complex procedures and processes and manual marks. They have to be automated and integrated with the existing ecosystems and legacy systems, in addition to device provisioning. So let's talk about the problem statement for this particular use case. So this is a use case for Sprint in USA. So with the evolution and exponential growth of 4G and 5G networks, the existing infrastructure needed complete overhauling, and the legacy systems were unable to cope up with the growth and could not scale and manage the new technologies. So they came up with the new design, which was energy efficient and more compact infrastructure, but it required massive deployment. And for that, you need huge budget, huge manpower, and huge OPEX. Additionally, the manual deployment was very, very slow and error prone. So coming to the last bullet, this is where this also gave us the opportunity to standardize the greenfield as well as the brownfield devices. So this is where Cisco customer experience team stepped in. We started engaging with the customer's team, came up with a solution which included industry standard tools like NSO, technologies like ZTP or zero touch provisioning for the new 4G and LTE network infrastructure. Also, insertion of BPA, the business process automation platform, offered a simplified and unified user experience by automation of workflows, integration with the existing tools and systems. The 2 main use cases are So first one, what we did was to prep the existing network, making the existing network and the ecosystem ready for the expansion of new routers by configuring the ports and services on the brownfield devices. Once the network is ready for the new infrastructure, then we did the pre-commissioning and onboarding of the cell site routers using ZTP. So in the next slide, we'll just go over the overall architecture. So as you can see, NSO is the centerpiece of this solution, where it is managing devices in various franchises, and namely wireline and wireless here, and in a distributed fashion. Also, NSO is managing multi-vendor platforms like routers, switches, firewalls, etc. It is aided by BPA on the acting as an outbound system to NSO, which is automating the workflows and talking to the inventory and other systems. Once the new devices are provisioned, they're also registered to monitor a system like Cisco Prime for future monitoring. With this, I'll invite Krishna to go over the use case details.
Thank you, Sandeep. So as we peruse through this solution architecture and the implementation approaches that we would see in the later slides, we'll observe that cell-site router services are bolstered by leveraging NSO from multiple dimensions and in some cases in a very unorthodox way. So the service catalog app on BPA UI or the BPA API provides capabilities to provision and manage all services via NSO. Various users are able to place orders, approve, delete, or delete these various services within BPA based on role-based access control privileges. Some user groups include admin users, service engineers, service admins, viewers, etc. All these services are inherently exposed via a REST API for consumption and management by external systems, such as APN in this case. APN is Sprint's internal platform that encompasses its payload or CIQ data inputs. As NSO facilitates provisioning of various services, BPA serves as a platform handling macro transactions spanning across multiple NSOs, and in this case across wireline NSO and wireless NSO. And each NSO is earmarked with a roster of devices to manage, such as the edge router, the Cisco devices, the Juniper devices, the cell-site routers, etc. Devices with operational monitoring platforms such as Cisco Prime for operational maintenance. All these services in this architecture are deployed as microservices on a Kubernetes platform. We'll observe that my workflows serve only as a thread execution engine and are absolutely devoid of any business logic. What this would mean is services are able to expand or diminish as necessary from say like 3 container deployments to 30 container deployments to 10 using. So a quick overview of the first use case for technology additions, aka a port turnup service. TechAds require enormous configuration on the backhaul network for technology augmentation on cell-site routers. Cell-site routers enable the mobile backhaul networks with routing and switching capabilities. Edge, eNode D, BTS, or gNode D port turnup service provisioning in brownfield networks for service activation is accomplished using defined stack service models in NSO. As part of the macro transaction, BPA workflows also invoke various NSO instances to perform delta configuration on uplink devices such as Juniper or ASR9K edge routers or IPAs, etc. Transactional atomicity across wireline and wireless NSOs are ensured with automatic rollbacks if necessary during partially successful operations. orders placed with CIQ data are vetted against inventory matrix to ensure the availability of requested VLANs, port assignments, etc., even prior to the commencement of service provisioning. Inventory matrix is stipulated by Yang-based data models that are stored within NSO-CDB. So we use NSO-CDB to store the inventory data. Myriads of pre-check procedures, including several hundred commands, the cheat sheet that Sandeep talked about, are executed via NSO Live Status Exec APIs on these devices to verify deployment readiness. Pre-check reports are then stored and preserved within the order tracking page for future reviews by operators for compliance and audit purposes. And then custom business process workflows have been crafted for not only sunny day scenarios, but also for failure remediations, for rainy day scenarios, and to send out appropriate notifications. BPA here is performing order lifecycle management for provision services through the entire gamut, ranging from performing future service updates, decommissioning existing services through NSO, to generating compliance reports on provided approvals and preserving the committed device configuration corresponding to various sub-services. So let's take a quick preview of the snippet of stack services that are used for the port turnup or the TechAd service for the use case 1. So stack service, to begin with, makes it seamless to let the received CIQ payload decide which child stack service would get provisioned. The example flashed over here are Yang models deployed on two different NSOs, namely wireline and wireless instances, though we can see two different service points here, right? Reflecting two different services on two different NSO, we can observe a leaf node named service key, which is common on both these services, or both these service model definitions. The same, the order ID that is generated in BPA at the time of placement of order is assigned as a service key for both these service instances. And the unique service key node value is leveraged for binding together various disparate service instances and stitching them together and managing them as a part of a macro transaction. The value provided for leaf node enable validation determines if the validation microservice would get invoked by the workflow or if it would be skipped altogether. So what are these validations? So we validate the veracity of the received CIQ input payload data to ensure that it corresponds with the reserved VLANs, ports, TechAd types, etc., loaded in the inventory matrix. So, for example, TechAd type should be a valid combination for the original equipment manufacturer (OEM), such as Samsung, Alcatel, Lucent, or Ericsson's devices. Ports must correspond with the ones that have been reserved for the OEM and the TechAd type. VLANs must correspond to combination valid for OEM types and the backhaul design. So if the CIQ data is submitting the order with mismatches or with non-reserved ports, the progress of the workflow is stymied and explicit validation errors are displayed in the validation milestone description as shown in the screenshot. As we can see, there is a validation error that's thrown. Validation is the first step that happens post submission of the order. So we are able to identify that at a very early stage so that we don't have to do any rollbacks or endure through the management of partially applied configuration on multiple devices, on multiple NSOs. So the validation logic itself is written or coded within the microservice, and hence it is very easy to enhance from like 3 container deployments to 30 container deployments to back to 10 container deployments, depending on how many concurrent requests we want to handle to perform these validations, as they're all deployed on Kubernetes-based microservice containers. So, let's look at the inventory model, inventory management Yang models. So Yang model definitions shown in this snippet on the left and in the middle are were crafted to load sprint inventory data related to what is referred to as preload data YANG container. So static routes, BFD, preference data, tech ads. So these are some examples or components of preload data loaded into NSO CDB, and they can be updated, modified, manipulated using some of the action points that we have defined. So NSO action points that would actually load them onto NSO CDB to begin with, and then help them manage them as displayed in these action point references on the right. So the YANG container named preload encompasses all inventory related data. So it is stored in NSO CDB. So the inventory data from NSO CDB is fetched by validation microservice from components of preload container node via REST API call. If you observe the URL here, this is the NSO IP address. It is calling the preload container node, right? We are accessing the node in the resource URL. And then we get a complete response, and the validation microservice is able to perform corresponding validations for each inventory element, such as tech ad, BFT, preference, static route. Let's take an example, right? So for example, if we have a switch OEM type that is ALU, so we need to make sure that the tech ad type that is provided is valid for this OEM type ALU, or the one provided here, DBA1 CDMA 1900 corresponds with the OEM type ERC. So similarly, the ports provided for this tech ad order for ALU and this tech ad type MIMO TDD can be one among Gigabit Ethernet 035 or 0013 or 00013 based on what device type we are dealing with. So similarly, the VLANs here can be either 4 or 5, depending on what backhaul design we are dealing with in the payload response. So the response encompasses data of various subcomponents here. We can also see that there are some validations that we do with respect to the static route data to make sure that if the OEM type, in this example, is ALU, we ensure that the VLAN ID that's been requested is 16, and the verb for a verb that is CDN. So there are multiple such validations that happens inside this validation microservice. Any changes in the logic would absolutely require no changes to the workflow itself, as the workflow, which actually is responsible for calling this, is decoupled from the actual business logic that is within the validation microservice. So what this does is, if there are 3 validation microservice containers in Kubernetes, 3 concurrent requests can be handled without having to make any adjustments to the workflows, right? Like a simple, single Kubernetes command line command can scale up from like a 3 container deployments to 10, if 10 concurrent requests are to be handled on a temporary basis. And then it can again be scaled down to 3 over the same command. So we also, in order to, so the slide here also has references to some action points that are useful for loading this to begin with. As we can see, we can load all of them together, or we can update each subcomponent within the preload inventory data by invoking the corresponding action point reference. Moving on to pre-post checks. Pre-post checks are pretty much part of every maintenance window now are executed prior to and after every update in production. Often these commands run into several hundred or sometimes into thousands. That's probably why maintenance windows are very hideous to manage, and these commands are extremely hideous to execute manually in a sequential manner every time. So the process template app within BPA allows myriads of these pre-check commands to be executed on the device in a preferred execution sequence, and they can be called out with a pass or a fail response based on the definition stipulated by the operator. So process templates app within BPL leverage NSO's live static exec APIs to execute them on devices and class response outputs to ascertain passing or failure conditions. Operators can simply come back after it's all executed to view the summary report like this, or they can expand on each of these commands and see a more detailed execution and the output obtained from the device. Individual rules can fail, but overall Precheck template, which here is TechAd Precheck CSR macro, can pass based on the condition that's been defined. So if the condition is defined to say that it requires passage of rule 1, 2, 3, or 4, and 5 and 6, then it can still pass. Device command outputs requiring a simple parsing, such as in this example, where we are just looking for contains, no IP address or invalid input or incomplete command, can be parsed through a simple regex string definition as shown in this image. But there are times when device command outputs require more complex parsing and conditionalities applied, and they can also be handled through an alternate mode of text FSM templates instead of the regex strings in the process template definition. Text FSM is an open source project championed by Google to transform Cisco, Juniper, Alcatel, Ericsson, and other device CLI outputs into Python dictionary objects. It's easier to handle any level of complexity and parsing within Python scripts. So as you can see, the text FSM template that we are using here is Cisco iOS show run interface service template, and then the analysis script is the TechAd Precheck CSR mini macro analysis.python. So this can be added, manipulated, edited through UI. The business logic for both the regex-based approach and the text FSM can be manipulated on the UI through the process template apps, and the workflow is just going to invoke the stipulated process template name, which here is TechAd Precheck CSR macro, and it's going to call that any changes within requires absolutely no changes to microservice or the workflow. That completely decouples the workflow from the implementation logic. So if there are, what this means is if there are like multiple execution desired, since process template app is also a microservice named command analyzer that is deployed on Kubernetes, and workflows are also a microservice. So workflows as part of order fulfillment would just call these process templates, and if concurrent executions are desired, Kubernetes can be scaled to increase the number of microservice container deployments to 10 or 30 or scale it down as desired. So any changes needed on these templates can be performed via UI. So we can also go back and look at the past executions that have happened as part of order fulfillment through the workflow or as part of these manual executions. Historically, we can click on the executions tab. We can see the past executions. We can filter them based on the template name or execution date or result or what NSO instance we are dealing with. Clicking on this eyeball icon will open up a detailed summary report and a detailed report. Just to give a preview of how is this implemented under the hood, we, in case of Juniper devices, we make a reference to a netconf exec action point, and as it's defined in this YAG. And in case of Cisco devices, we make a reference, we invoke the action call point exec command and using the exec command method implementation, as we can see here. And whatever response is returned on the device during the execution is returned here, or if there are error messages that are returned by the device, we return that as well as part of this response. So moving on to like order lifecycle management, service orders are unique records that manages the lifecycle of the order using defined workflows. Snippet of the master workflow for TechAd port turnup service is depicted in this slide. These tasks in the master workflow invoke sub-workflows, which in turn invoke corresponding microservices for business logic. For example, validation of service input task here in this invokes sub-workflow that calls the microservice for evaluation of the payload data with inventory, based on the example that we saw a few slides back. Provisioning of ER and CSR call sub-workflows which again call microservices to inherently perform functions such as provisioning, upgrades, approval, decommissioning through NSO, and audit and compliance reviews, alarms, and notifications are being sent out as well as necessary. And if there are rollbacks, if there are partially completed operations at any time, NSO transactions are atomic, but since we are dealing with multiple NSO transactions at a macro level, if we want to roll back everything, if some of the transactions have not completed, then these workflows, sub-workflows are inherently built to perform automatic rollbacks. So let's take a quick look at the high-level milestones for the TechAd service. To begin with, like we discussed, the first thing we perform is validation of the service input to make sure that the validation milestone is successful. And then subsequently for provisioning of ER, we progress through various milestones, including performing checksings, NSO checksings on ER devices, pre-checks on ER edge router devices, generating a dry run. If approvals are needed by operator, if approvals are not needed, they are just preserved in the internal databases, and then a commit is performed on edge routers. We go through a similar path for CSR devices, and based on at what point there may be failures, we roll back from that point. So all these milestones listed here are indicative of what the operator would see in an order tracking page. Once they place the order, they can see the advancement of various milestones. And we'll have a slide later where we can, which would depict that progress of various milestones. Again, orders within service catalog and workflows are also microservices deployed in Kubernetes, which means these again can be expanded at will to scale as per necessity to handle concurrent requests. So service order catalog items are based on form builder forms. So form builder is an app within BPA. Form builder forms are dynamically generated, dynamically rendered based on defined Yang models in NSO. If updates are performed in the service Yang models to add a new Yang leaf node for the second subnet, let's say we have subnet mask 1 here, we want to add subnet mask 2, and then we perform sync services on BPA, we are able to imbibe the updates done on the NSO service models, and the form would be regenerated to reflect that. So that will really make adding new forms pretty easy for new service catalog items. In addition to constraints such as when and pattern that are also part of the Yang model, we can apply additional constraints, additional regex strings on these forms if needed through UI as well. So form data can either be filled out or it can be imported by clicking on this upload button at the top right here. Once it's been filled out and click on the order now button, an order number is generated, and a BPA tracking ID is also generated. So this BPA tracking ID is very critical, as this is the one that is referenced as the tracking number and it is assigned as a service key Yang node value to multiple services as part of the workflow. And the order tracking page displays a listing of various orders in various states, such as in process, failed, completed, deleted, paused, etc. Here, paused orders are the typically ones that are requiring user approvals or actions. So as you can see, there are multiple tabs here, such as all orders, TechAd, ZTP. Based on the catalog items, if we need to filter, sort based on like generic attributes here, order number, tracking ID, etc., then we can retrieve them through the All Orders tab. And if we need to sort, filter, look into these orders based on custom attributes, we can click on these order tabs, and then we will get records that pertain to only those order types, and then we can hit on the filter button, and then we can filter for a completed order, or based on order number, or based on an OEM type, which is custom attribute for that order type. And let's look at the 4 buttons that are visible under the action column here in this layout. So, these buttons are for order tracking. We can click on this to see a more detailed report on the order. This is a high-level milestone. This is view order details, which reflects the payload data that was submitted. And then this is a delete or a cancel order button that is available for non-active or completed orders. As you can see, you won't see this for a failed order or for a deleted order. Deleted order because it's deleted, nothing to roll back, and for failed order because failed orders are inherently rollback, so there's nothing to roll back as well. But what's interesting is failed orders have an option to retry, resubmit. What they'll do is they'll re-trigger a new workflow instance with the same payload to kick off if that's desired. So we in the solution architecture slide, we saw that there are multiple personnel such as service admin, service engineer, platform admins who perform various functions for service activation, and their roles are managed by RBAC at various service workflow and app-based privileges. The screenshot on this slide depicts a dashboard view for service admin to define and manage definitions within various apps. The sample dashboard view for service engineer in the next slide right here depicts access to a lesser number of apps and even lesser limited functions within those apps. And you will also see that there is not an admin option here, menu option here. Typically, a platform admin would have an admin option to go and have more advanced functions there. Just at a quick level, so we briefly talked about Form Builder, which is responsible for creating new forms, dynamically generated forms. Device Manager app here is responsible, reflects all the devices managed by all NSOs that this BPA instance is attached with. So all functions such as check sync from, view configuration, add devices, modifying auth groups can be performed through this Device Manager app. Service Catalog app is the app through which these orders were placed. Order tracking can be performed. Some of the few order tracking screenshots that we saw in the previous slides are from within the Service Catalog app. Process Template is the app that's used for executing pre-post checks. All the reports, pre-post check reports are displayed from retrieved, can be viewed from Process Templates app. Golden Config Templates app is something that we would talk about. I'll keep the suspense until we actually talk about the Golden Config Templates in a later slide. Workflows is where we have all these workflows defined for various orders. So each of these service order is tied to a workflow so that they are able to play the separate order instance can be initiated. We'll talk about the device activation app, which has an inventory of devices that would be ZTP'd in a later slide. So all of these apps are, you can think of these apps as like a microservice container that's deployed on Kubernetes with like 3 container deployment instances and can be scaled up or down based on the necessity. If we have an admin user with enhanced privileges, platform admin user, they have an ability to come to the admin menu, add controllers, as many NSO controllers as they want. Clicking on the view, the eyeball here opens the details pertaining to the NSOs. And there is also a custom settings tab here that can be created. Some of the static values that would be used and we don't want to pass them repeatedly through the payload can be stored here and retrieved dynamically. We'll see an example of this in a later use case. And they can be added here. And then clicking on this button over here would do a synchronization or a sync from for the device model on corresponding NSO. Clicking on the sync services schema would synchronize the various service points across various NSO. As you can see, there are some service points from wireless, some from wireline. So it is very beneficial if you want Form Builder form Xboxes drop downs to be auto-generated or updated and rendered in service input forms. So moving on, jumping into the second use case with zero-touch provisioning for cell-site routers. That are used to expand 4G, 5G coverage scale by onboarding new greenfield CSRs. So as soon as a procurement order for a new cell-site router is placed, Sprint's inventory system would get updated, reflecting the intent to onboard these cell-site routers sometime in the future. Synchronization with inventory databases fetches a roster of future CSRs to onboard. So we saw an app called as Device Activation in the dashboard view a few slides back. So what that does is clicking on that Device Activation app launches a view like this. So as soon as the app, the CSR has been added to like a customer's inventory and a sync is done, we would see that would be listed in this manner with an onboard status listed as waiting. And it will continue to remain in the waiting state until until it is ready to be completed, until a tap arrives during ZTP process, and then it transitions to the completed state. So let's go back to the previous slide. So, so pre-commissioning steps, and as soon as the order is placed for a pre-commissioning, pre-commissioning is required for any ZTP, because pre-commissioning steps are services that are provisioned using NSO on auxiliary devices as prerequisites to support the future onboarding of these CSRs. Pre-commissioning orders, again, can be placed through the service catalog order page, and as soon as the order has been fired with CIQ input, we will see the operator can just wait and watch, can see that all these steps are in a waiting state, and as the progress happens, they can see it transitioning from orange to green or red if there are failures or requiring user actions. But it will transition into green with the successful milestone completions on over here. So all these steps can be viewed through the milestones at tab here. So, once pre-commissioning, pre-commissioning and the inventory upload synchronization can occur several weeks or months ahead of the actual D-Day, when the technician walks into the data center, plugs in the cables onto the new cell-side router. The new entrant would be discovered by the DHCP server, would assign it a temporary IP, push some skinny day zero config via TFTP. Once day zero config is loaded on the CSR, traps would be sent out to BPA, and BPA SNMP trap listeners are waiting. So it will be at this point here, and they would be waiting for a trap to arrive. And once the trap arrives, using the local IP address specified in the trap message, BPA queries new CSR device to determine its cascade serial number. But how can we query a device which ain't listed in NSO using NSO's connection adapter? Serial number of the CSR is obtained. So we use the NSO connection adapter allows devices that are typically not onboarded added onto NSO allows us to execute both commands on a config mode and a non-config mode. The parameters that are needed to using this adapter are host name, port, username, and password. The snippet on the right has an implementation example for running it on a config mode and on a non-config mode. So once we make a query and it attempts to get the serial number, and then once the serial number matches with the one listed over here, it knows that it's not a nefarious entry, and then it does a device activation. It adds it, it starts the process to add it to onboard it to NSO, but does a validation prior to onboarding it to NSO. It does a device onboarding using the auth groups, and then on a successful, it then goes through plethora of steps on the cell-side routers on wireless NSO and then on wireline NSO to provision various services such as day 0, day 0.5, day 0.75, day 1. These are some sub-services that are referenced within the milestones. The operator is able to see all these progress happening on their screen by just watching this. So it's interesting, we change the IP address of the device that's onboarded, and then we do some queries, we run some queries. So now that it's been onboarded onto NSO, we can use the NSO's live status exec API to directly query, run some command, get some dynamically assigned values. When the CSR was getting powered on, we can get some dynamically assigned values, and then we can manipulate them using what we call as golden config templates. Right, but how can we do that? These are values that did not go through an NSO service. These were auto-assigned. So NSO service is not aware of it from a service point of view. How can we usurp them? How can we manipulate them? So golden config templates within BPA would help facilitate that, will help us do that. So it's similar to the load merge functionality that we might have seen observed in NSO CLI. So golden config templates can, such as these, can take in variables that can be passed through payloads that will be queried through process templates by live status exec API, or some static values that are loaded through the admin menu. So we saw that there were some settings that can be used to add some values there. It can be queried from there. So in this case example, like we can select one or more devices or a device group, and then we can do a commit dry run to render what would be the dry run output for applying this directly at a device level instead of a service level. So we can see the response output for multiple devices. We can view them in native XML and CLI formats. And the API that would be useful for running a commit dry run and commit are as listed over here in this screenshot. Again, GCT is also a microservice that's deployed on Kubernetes workflows as part of auto fulfillment. We'll just call this GCT template name, GTPCSR day zero add with variable values or static values, right? For them to be executed using process template. If there are several concurrent executions, Kubernetes again is our friend here to scale up, increase the number of GCT microservice container deployments. So final milestone here is the addition of these devices to the Cisco Prime. As we can see, it's the last step, but it's not the least. It's very important for operational maintenance. We add them to Cisco Prime. So we are doing an integration with the Cisco Prime with adding it to the unit key, and we are making an API call to add it to Cisco Prime for element manager monitoring. So to make sure that the ZTP CSRs are available for monitoring. So clicking on the order track, we saw that the milestones were displaying various statuses, milestones. Clicking on the configured devices tab within the order tracking page will show the list of devices that were configured as part of this transaction or workflow. Clicking on the eyeball icon here, which lists the committed device configuration. If there are multiple sub-transactions that happen, we can click on one of them. In this case, we click on day 0.5, and we see the dry run or like the committed configuration that was committed on each of these devices. We can download them by clicking on the individual download items, or we can download them in entirety by clicking on the download all button over here. And clicking on the second icon here, which will help take us to the process execution summary report, which would launch a form like this. And we can again click on based on how many process templates were executed at what point as part of whether it was executed for day 0, day 0.5, day 1. We can click on the corresponding report. It will launch a new tab. And as you can see the report that is listing out all these commands. And there are several hundred pre-check commands that are executed over here. So again, this can be downloaded in a PDF format or in an Excel format by clicking on this PDF download in PDF or download in Excel buttons over here. These are preserved. Even if the order is deleted, as you can see, even if the order is deleted, these are preserved so that they can be useful for future compliance and audit purposes. So with that said, I'd like to invite Sandeep back again to go over the bottom line and the business outcomes that were fructified as part of this solution implementation.
Thanks, Krishna. That was a real in-depth walkthrough of the use cases. So we started this presentation with the problems or challenges faced by the customers. And then we walked through the solution. We talked about the solution, but what have we achieved? What have we gained with this automation? What are the business outcomes? Let's have a look. So this solution provided a standardized and centralized management for existing and brownfield devices, greenfield devices, and also lifecycle management of the services powered by NSO. Also powered by BPA, it provided a single unified tool to manage the business processes and customer workflows, and also the integration. Also, to cope up with the unpredictable market demands, it provides a flexible platform which can easily scale to take care of the expansion. Sometimes designing and developing automation solutions are Krishna, can you see my video or not?
I can.
Okay.
Maybe are you still saving on your bandwidth?
Yeah. So sorry, we are facing some network challenges. So sometimes designing and developing automation solution can be complex and painful, but once deployed, it has recurring and repeatable benefits. And with the reduction of deployment time and reduction of errors by avoiding manual processes, ultimately it leads to faster revenue recognition and huge OpeEx savings. So we'll talk about the numbers in the next slide. So this is our proud moment where we can validate the commitments and promises made to the customer. And the numbers speak for themselves. 4 million of saving per year just for the ZTP deployment. And it is not only about cost saving, but the overall experience, the user experience, like providing single source of truth and providing managed services, getting rid of never-ending truck rollouts, and then reduction in frequent and long night maintenance windows. And the most important, the deployment rate increased 10 times, tenfold. That was the biggest achievement. So all put together, it resulted in huge cost savings, faster growth, prevention of network outages, and also gaining customer confidence. This is the value we deliver. Thanks a lot for listening. We appreciate your time. If you need further information, please contact us at these email IDs. Thank you once again.
Yeah, so we hope, hopefully we have unpacked various dimensions of NSO through our use case illustration for Sprint, so that service providers don't have to be tangled in a mesh image that Sandeep was sharing at the beginning with their network automation journey. It can be a more pleasant one. So don't hesitate to reach out to us in case of any question. And thank you so much for tuning in today. We appreciate it.
Thank you.